So today we're going to continue our look at fractions, and we're going to look at combining, which means add or what? Subtract. But in algebra, we think of those two things as combining because what you're really using are the sign rules. And because sometimes when it looks like addition, you may end up what? Subtracting. It looks like subtraction, you may end up. Yeah, so you need to think of it as combining. Algebraic fractions. Now, all right, so we've already discussed in a previous section of the number section, we've already discussed how to add or subtract or combine fractions. But, of course, having the letters, the algebraic things, complicates it a little bit because there's a little bit more stuff in there. The good news, though, is just like when we multiplied and divided, the rules for fractions never change. Good. The same rules still apply. But what you're going to have is you're going to have more of it. Okay? So what I want to do first of all is I want to remind you of something. I want to remind you of something about fractions that you may not remember. And that is, okay, remember that when you have a fraction, you have some numerator over some what? Denominator. What you may not remember is no matter what your fraction is, that numerator and that denominator are always enclosed in a bracket. Now, if it always happens, do they ever write it? No. But when you're working with algebraic fractions, you may want to write it. Okay? So, you may want to write the brackets if you have more than one term in numerator or denominator. So go ahead and write that down. You may want to write the brackets if you have more than one term in either the numerator or denominator. Now, we couldn't do that. We didn't have to before because we were only working with numbers. So there was never more than one thing in the numerator or denominator, right? But now we could have x and a y or x and a number. So you can have more than one term. And when that happens, you need to be aware that even though it's two terms, it's one numerator. Okay? Does that make sense? How many names do you have?
Four.
4 names? Okay, 4 names.
I have 3.
Right? You have 3, right? Okay, so all of those names belong to you, right?
Yes.
So that's all of you. They're all yours. They're all yours, and they all describe you. Well, the same thing is here. You may have 3 terms in the numerator, and they all describe the numerator. So am I allowed to get rid of one of them?
No.
Yes.
No.
Get rid of it.
Okay?
What if you mix 2 names together?
Okay? No, don't get carried away. Or creative. All right. So, if you have more than one term in the numerator or denominator, your best bet is to simply enclose it in a what? Bracket. And I would just do that first. Get used to it.
Wait, in 2 separate brackets or one bracket?
Just one, wherever you have more than one term. So, for example, if you have x minus 1 over 2 plus 3 over x minus 2, where would I want to put brackets? Around the top up there and what?
The bottom down there.
Right. And what it does is it holds them together because that numerator is not an x and a negative 1. That numerator is a what? X minus 1. Even though it's 2 terms, they are 2 distinct terms, but they are one numerator. In the bottom, how many terms? Right there? 2. It's 2 terms, but it's one denominator. Does that make sense?
Yeah.
Okay, so close them together. Now, we don't usually think of those brackets, but they are helpful sometimes. And so it's just better, it's just a good habit to get into to write them if you see them. Okay?
Give me one
especially as we move forward and you start doing more and more complex fractions. Okay?
I don't get it. Hold on.
All right. If you have more than one term, just enclose it in a bracket.
Enclose them all in a bracket.
Well, so like here, we have more than one term. Did I put a bracket around the 2? No, because it's only one term. I didn't put it around the 3 because it's only one term. Only the ones that have more than one term.
Have you put it around all of the both of the terms that are...
Right. You put it around the entire numerator.
Okay.
Yeah, it's not all of them. You just put it around the entire numerator. Think of it as one thing. Okay? All right. Now, a lot of times students forget to do that. Okay, you copy off some other because I've got to move on. Okay? Now, guys, so today what we're going to do is we're going to talk about adding and subtracting or combining fractions. And the first rule is that in order to combine fractions, what do we know about the denominators? Do you remember?
It's at the bottom.
That's the bottom number, but what do we remember about when you're combining?
They keep the denominator.
Yes, you must have a common denominator. In other words, those denominators, in order to combine them, they have to be identical. And now remember, think back when you learned about fractions. Fractions mean pieces of an object, right?
Yeah.
The denominator tells you how many pieces you have. And so I'm sure all of you played with those toys where you had like things that were cut into fourths, right? And they were one size. Then some things that were cut into eighths, which were another size. They're smaller, right? But then so you can't put the fourth ones into the eighths one, right?
I've never played with those.
Okay. But anyway.
Maybe just
I thought you were talking about the fruit that were
So.
like the Velcro kind of stuff.
Anyway.
Like
So, the pieces are different. The sizes are different. You can't put them together, right? So they have to be the same size. And the denominator is the thing that tells you how big or small something is. So they need to be the same size. So in other words, they have to have a common denominator. If not,
You have to get one.
don't put A, I'm sorry, I don't know why I wrote that. If not, you must find the LCD, which stands for least or lowest common denominator. Both of them mean the same thing.
Mr. Self,
Yes.
does that still go under number 1?
Yes, it's just under number 1. Yeah. So if not, you must first find the LCD. You have to have a common denominator. Now, did we need a common denominator to multiply?
No.
Did we need it to divide?
No.
But we have to have it in order to combine. Okay? And that is a problem for students because that's why one reason you don't like fractions is fractions don't behave. Well, remember why they don't behave? Is a fraction a number? Nope. A fraction is a division problem, isn't it? And so that's why they don't behave. That fraction bar is actually the division symbol. So that's why they don't behave like numbers. Okay? They have their own set of rules. Okay. Now, to find the LCD, I showed you this process before. And when I showed you this process before, I told you that I use a specific process if the upside down division, exactly. If you like it, use it. If you don't like it, but you have another method that works, then use that method. Yes, ma'am. I'm sorry. I wasn't ignoring you. Yes.
This is still under number 1, isn't it?
Yes. Still all under number 1, right? Talking about the denominators. Okay? Okay, so, and again, I'll remind you of the steps and the processes. It works even when you have algebraic fractions. It never stops working. So, first, write the denominators in an upside down division symbol. Just turn it upside down. It can be upside down.
Be the exact same.
you mean that one. Oh, I thought you meant
That's
the
upside
line
down.
and the two dots.
Yeah, it is. I just turned it upside down.
What is the extra line?
Division is usually written like that. I just flip it over.
Upside down.
When is division written like that?
Well, when we're doing this. All right, now.
Oh,
Come on, guys.
That's not the well,
No, that's not.
All right, come on. Then, second, divide out any factors that are common to all the denominators. Remember, factors means anything that'll divide in how? Evenly, right? So anything that'll divide in. So it can be a number, it can be a letter. So remember, it's common factors, just like when we were simplifying. You're doing the same process as when you were simplifying them. Look to see what's common and divide it out. Okay? And when you divide something out, it's going to go out here outside the division symbol, right? So you have your things inside, then you divide it out. We're going to look at plenty of examples if you don't remember. Once you get the answers, whatever you divide, they just go down here, right? Continue until there are no common factors.
what if there are no factors at all to start with?
Okay, excellent question. We'll talk about that. Okay? Yeah, because not everything's going to have something common, are they? Good job. All right. So, let me put step 4 here. Okay? Then you simply multiply everything on the outside to get the LCD. That's why we do this upside down division thing. It keeps the stuff we don't want separated from the stuff we do want.
This was some. This
Okay.
is the start of.
Wait.
This is the start of the division thing. I remember it from the
Okay.
taste
What's
when
the
I did
word
this
after
bit,
there?
and I picked up every time of it.
Everything.
Yeah, 'cause I
Sorry,
did this.
everything on the outside to get the
Can
LCD.
you do an example like a?
Oh, we're gonna do several.
Numbers? Yeah.
We're gonna do some numbers. We're gonna do some with numbers. We're gonna do some with numbers and letters, etc. Yeah, you bet. Absolutely.
Wait, I didn't.
Okay.
I
All right.
finished mine.
Okay. Now,
I haven't because I find it so
all right. So what I'm going to do is, I don't even care about the numerators because all I'm worried about is the denominators. So let's just say we had a denominator of 8 plus something that had a denominator of, I don't care, 12. Okay. Now, the old elementary school or primary school way of doing that would be just say 8 times 12, which would give you a ginormous number.
Wait, we did that in primary school?
I did that.
Some of you might
I
have.
don't remember doing that.
Anyway.
I did divide fractions.
Guys, anyway, the old shortcut for some people who did it, but that doesn't. It's a terrible method. Don't do it because it gives you a number that's way too big. Come on, guys, focus. Don't focus on the wrong thing. So what we're going to do is we're going to find it. So are 8 and 12 the same denominator? No. So we're going to build a common denominator. So just put your 8 and 12 in your box, right? What will divide evenly into 8 and 12 at the same time? 4. Now, what if I had divided by 2? I could have divided by 2, but that means I would have had to divide again later. It's perfectly fine. And I'm going to show you that as well. Now let's divide. 8 divided by 4 leaves you what? 2. 12 divided by 4 leaves you what? 3. Is there anything common to 2 and 3? No. Other than 1, but it doesn't do you any good because you get right back to where you are. Okay? Now, so there's nothing common. So all I'm going to do is take everything on the outside and what? Multiply it together. What's 4 times 2? 8 times 3 is? So the LCD for 8 and 12 is 24. Okay. Now let me show you again the same exact problem, but let me show you what happens if you do it with 2 first. Because some of you are going to be comfortable dividing with big numbers. Some of you are going to see a smaller number, and then it just takes an extra step It's no big deal. So if you saw 8 and 12 would divide by 2, that gives you 4 and 6 when you divide. But what's common to 4 and 6?
2.
So you could do it again. And that gives you a 2 and a 3. And then you would just multiply all 4 of those things together. 2 times 2 is 4 times 2 is 8 times 3 is
24.
So you still get to the same result, right? So some of you, your division skills are stronger than others of you, right? So if you see a number that's obvious, use the number that's obvious. Is it more important to get it done quickly or correctly? Correctly, right?
Yeah, depends who it is.
All right? Yes.
So, you know how we got the denominator of 24?
Mm-hmm.
So when we're going back to the problem, do you have to multiply it to get multiply the numerator to get the
Yeah, well, we're going to use another pattern. Right. Okay? All right, guys. Let's look at another one. Let's say we had something over 3 minus something over 5. So we're subtracting, so that means combining. In order to combine, those denominators must be the same. Are they the same right now?
No.
No. So that tells us we need to get an LCD. So put your 3 and your 5 in your upside down division symbol. Hold on a minute. We're just following the process. And ask yourself, is there anything common to 3 and 5?
No.
Yeah. Not any other than 1. So in this case, they had nothing in common. So there's nothing on the outside to multiply together. So what do you think I need to multiply together?
3 and 5.
The stuff on the inside. If there's nothing on the outside, you can't multiply the stuff on the outside, right?
Exactly.
So you just multiply the stuff that's where? Inside. Okay?
Wait, let me write this one.
All right? So if they don't have anything in common, then you just multiply the 2 together.
Is that the same for plusing it?
Oh, yeah. Plus and minus are the same, right? Because they're both combining.
Are they?
Mm-hmm. Okay? Putting things together.
So in the
All right.
end, most of the time you're going to be multiplying.
No, but if
Well, you have to multiply something. There's going to be something to multiply. Okay? If you don't, because if you don't, that means you started out with the denominators being the same in the beginning.
What if you
Okay? Now, sometimes the denominators are the same to start with, so do I have to do anything to them? No. And we're going to look at some examples of that in a moment. Okay? All right. Good job, guys. So, let's go to the next step. Step B. If you change the denominator,
What is B?
step A was to get the common denominator.
That was not step A.
No?
This is what we have to stuff.
Okay.
no, my one's like that.
Oh,
This is
sorry.
What we have.
No, this is like
Do that.
No.
There you go. Here you
Put
go.
A.
Sorry, I just didn't put the A. There you are. I just forgot to put the A on the next on that step. Chill out. Give me a break. All right.
Steph, can you go back for a second? Can we just make it like, you know how it's all step 1? Can we just make it step 2?
No,
Step 1A, step
'Cause it's still part of it.
1C.
it's still part of the denominator stuff. Just put it. It's not going to kill you guys. Come on. All right. If you change the denominator, you must also change the numerator. It's still it's just part of the denominator thing.
Dash, dash, the 1, 2, 3,
Okay.
4, dash.
You guys just make me crazy. All right. If you change the denominator, you must also change the what? Numerator. So let's talk about how to do that.
I'm going to
Okay.
write a space.
No, you're not.
I am.
Next page.
Turn the page.
I know, I'm annoying.
You must.
Okay? All right. To do that, first, write as one big fraction using the LCD. So in other words, you've got a new denominator, right? So you're just going to write it as one big fraction using that LCD. Because your whole point is to put 2 or 3 fractions together as what? 1. So write it as 1. Okay? All right. Then we're going to use the pattern. And I've talked to you about the pattern before. It's called divide, then multiply. Excellent. You guys are great. Right? Divide, then multiply. So let's talk about the steps for it. Divide the LCD by the denominator.
And multiply that number to the
Exactly. Multiply that quotient. Oh, I can't. What's the big word? And I'm whistling here for some reason. Quotient. What's a quotient? That's the answer you get when you what? Divide. You're going to have to use big words. Or math words, actually. Multiply that quotient times the numerator. And remember, when you're multiplying, use brackets.
Give me
You
2
divide
seconds.
the lowest common denominator by what?
The denominator. The original denominator you had. We're going to look at some examples. Just write it down right now. I'll show you what I mean. Don't worry about it. You know I'm going to do examples so you can see what I
Now I know
mean.
how to spell quotient.
Good. Okay?
Wait.
Use
All right.
brackets.
Now,
Can I write use brackets in caps?
you betcha. All right.
No.
Here's a note as well. Okay. Any signs should move to the numerator. Just write that down and I'll show you what I mean in just a second. And that's all a good habit to get into from the very beginning, but you can do it now. Makes no difference when you do it, but do it. Okay?
I'm nearing the end of my page. Use brackets.
Okay. Multiply that quotient times the numerator. Use brackets.
Any sign should move to n.
Any signs should move to the numerator. So, I'll show you what I mean. Don't worry about it. Just write them down. Write down the directions, and then we're going to walk through it. Okay? All right. Are we ready? All right. Step 2. Okay. I did not put 1 and 2. Y'all did. Step 2. Combine the numerators. Guys, come on. Combine means any like terms can be combined, but watch those signs, right? The denominator stuff was all step 1. Step 3. Well, that's because y'all were arguing with me and you changed what was going on, so it's all right. Right? New page. You got a new page. All right. Step 3. Keep denominator. Don't change it. Once you got the LCD, you don't change the denominator. It stays the same. Okay? So be careful. I'm going to show you what I mean by that. But if you write it as one big fraction, then you don't have to worry about it because it's already one big fraction, right? The denominators are all the same. Finally, simplify if possible.
It's
Now.
a lot of work we really could have just like.
Yeah.
Why did we do all that? Can't you just go?
Okay, so these are not even algebraic. So let me walk you through the process. The most important thing you can ever do is identify the operation, because if you don't know what operation you're going to do, you're not going to know what rules to use. Yes?
Yeah.
So what operation is indicated here? Addition. With what kinds of numbers? Fractions, right? Because adding and subtracting fractions, in other words, combining, is different than adding and subtracting 2's and 4's, right? Now, in order, guys, come on. In order to combine fractions, we must have a what? Common denominator. What are my denominators right now? They're both 6's, right? So that means that I already have a common denominator. So I'm going to rewrite the fraction with my common denominator. But since the denominator is already the same, did I change the denominator? So am I going to change the numerators? No. So I'm just going to take the 2 and the 3 and do what with them? Add them together and give me 5 over 6. Right? Can you simplify it?
No.
Then you're done. Okay? Now, again, just reminding you that sometimes you're going to have problems where the denominators are already the same. Now,
I thought you were going to say like problems as if you're going to have problems
Does
doing
that
it.
make you angry looking at how they work it out?
no, just... All right. Here we go, guys. So, looking at this one. What operation is indicated? Addition, which we think of as combining now, right? Okay. We're combining what kinds of numbers? Fractions. In order to combine fractions, guys, are these algebraic though?
Yes.
No, because they don't have any variables in them, right? All right. So, when you're combining fractions, what must you have? Common denominator. What are my denominators right now?
4 and 6.
Are they the same?
No.
So that means I need to build a common denominator.
2.
So my denominators are 4 and 6. Shh, guys. What will divide into both 4 and 6? 2. If you divide 4 by 2, you're left with
2.
6 divided by 2 is 3. Is there anything common to 2 and 3? No? So we just take everything on the outside and what?
9.
Multiply it together. 2 times 2 is 4 times 3 is 12. So my LCD is 12. Right?
Yes.
Okay.
So it's 12.
All right. Now, I'm going to rewrite my fraction using my my new denominator, right?
Now you just have to go 3 plus 1.
So my new denominator is 12.
Oh, you have to do all of that.
But if I change the denominator, what else must I change? The numerator. And I'm going to use that pattern, and the pattern is called what? Divide, then multiply. I'm going to take the LCD and divide it by the denominator. I'm putting it in bracket. Why? Because that means do it when? First. And then I take that result times the numerator. So what is my LCD? 12. What is my first denominator?
4.
What is my first denominator?
I said it.
4. You did. 12 divided by 4 is what? 3. I'll take that 3 times my numerator, which is also a 3. And remember, when you multiply, use brackets because you're going to see there are more terms in some of them. So what does 3 times 3 make? 9. So that's my new numerator.
12 divided by 4 times 3.
Exactly. That result times 3. Now, do you notice this plus? Where does that plus need to go? In the numerator, so you don't lose it. So right now, that's a plus 1 in the numerator. Move it up there. I should rewrite these because I'm not getting enough room. Now, let's do the second one. It's 12 divided by what? 6 makes what?
3. No, 2.
2. And 2 times, what is my numerator? Positive 1. Why do I need that positive? Because I've got to have a sign for the second one, right? The first number doesn't have to have a plus, but the second one does. Hold on just one second, Emily. I'm not ignoring you. 2 times positive 1 is positive 2. Yes, ma'am.
Can you just say, like, you know how you have a fraction? Looks like times the 4 by 3. Do you just times
It-
4 by
it-
3?
What? Yeah. But you're just doing the division in your head,
But it's just...
which is fine. Which is fine. Yes. All right. Now, it should be painfully obvious what to do next. Why?
Because it says it right there.
It says it right there. 9 plus 2 is what?
11.
Over what?
12.
Will it simplify?
No.
Then you're done.
Yay!
Okay?
What is the closest thing that it would simplify?
Well, That's
I
just
don't vote, but what would be
It's only been 10 minutes.
that's it. It can't.
21 over 22?
No, it can't. All right. Yes.
You can't do things like 5.5 over 6, can you?
No.
Oh, sad.
Okay.
It would be
Let's look at another one.
Pretty much.
Okay. Here we go. Here's another one. So I'm just going to rewrite it so I have more space. So it's 2 over 5 minus 1 over 3. Now, if you would get into the habit of taking that minus and moving it to the numerator before you do anything, then you might not forget it later. But you can also do it when you're changing the numerators. It doesn't matter. But any sign between them must go where? Into the what? Numerator, because that's where you're going to use it. All right. Now, what operation do I have here?
Minus.
So that's combining, right? Combining what kind of numbers?
Fraction.
Fractions. In order to combine fractions, I must first have a what?
Common denominator.
Are my denominators the same right now?
No, you have to tie
No. If they're not the same, then that means I need to get what's called a LCD. So I put them in the upside down division symbol. But is there anything that'll divide into 5 and 3?
No.
So if they don't have anything in common, I'm simply going to multiply them together, which gives me an LCD of what? 15. If I change the denominator, what else must I change?
Numerator.
Using the divide, then multiply pattern. So let's do it. 15 divided by what first?
5.
Denominator. 15 divided by 5 is what?
3.
3 times what?
2.
The 2 gives me 6. Now let's do the second one. 15 divided by what? 3 gives me what? 5, which I multiply times the numerator of.
Minus 1.
So 5 times negative 1 is negative 5. Then what?
You do the math.
6 minus 5, exactly. 6 minus 5 is?
Minus 1.
No, just
Minus
6 minus 5 is 1.
Minus 1.
Oh. I'm sending you all back to the first grade. All right. Over what?
Please, I'm not even kidding to do it, because I think I probably would.
There
I
you
need to
go.
start from scratch, because I honestly don't know how to
Can we
work.
go?
I don't know my concept.
Okay?
Can we restart life?
Unfortunately not.
I ate
Okay.
a ton of bread for breakfast. Anything for breakfast? Well, usually I eat like a mandrill or banana, but today I ate a ton of bread.
Okay, here you go, kids. This one's for you.
To me,
You've got 3 minutes.
3 minutes, complete that.
3 minutes to do it. Then we'll talk to your neighbors, and then we're going to walk through it. And remember, I'm going to call on people. Go.
Is that a minus?
Yep. 4 over 7 minus 1/3.